Hi, I'm Richardson. Welcome to my talk on decomposing a monolith. I'm going to describe 6 key principles for refactoring a monolith to a microservice architecture. But first, let me introduce myself. I've done a number of things over the years. I created the original Cloud Foundry, which was a PaaS for deploying Java applications on EC2. That was then acquired by SpringSource and then VMware. For the past 7 years, I've been pretty much focused on the microservice architecture, working with clients around the world, helping them adopt the microservice architecture successfully. I have a startup called Eventuate, and my book Microservices Patterns came out back in November 2018. Here are the 6 principles. The first principle I want to talk about is make the most of your monolith. The monolithic architecture is an architectural style that structures an application as a single executable or deployable unit. If it was a Java application, it would be a WAR file or an executable jar. If it was a Golang application, it would be an executable. This architectural style is not an anti-pattern. It's perfectly appropriate for many applications. So you should make the most of it. For example, you're probably thinking about adopting the microservice architecture to accelerate software development. But it's important to remember that quite often the problem isn't actually with your architecture. If software delivery is slow, well, you should optimize your development process. You should heavily automate your deployment pipeline. You also want to think about improving team autonomy. For example, you can modularize your monolith to improve independent development. You can also reorganize your teams into cross-functional teams to eliminate slow, time-consuming handoffs. In fact, these are all the things that you will need to do anyway before actually adopting the microservice architecture. And also, if your technology stack is obsolete, you can just upgrade your technology stack by migrating to a newer monolith. You shouldn't automatically assume that you need to adopt the microservice architecture. It's only when you find those improvements to your development process and organization insufficient should you then consider migrating to the microservice architecture. You typically need to migrate to a microservice architecture when your large, complex application that's typically developed by a large team has outgrown its monolithic architecture. This then leads to the next principle: adopt microservices for the right reason. The microservice architecture is an architectural style that structures an application as a set of loosely coupled services. Each service is highly maintainable and testable. It's independently deployable. It implements a business capability or a business function, and it's owned and operated by a small team. The primary reason you adopt the microservice architecture is because it gives you the ability to deliver software rapidly, frequently, reliably, and sustainably. It gives you the testability and deployability you need to do DevOps. It gives you the evolvability and the maintainability that you need to deliver software sustainably over a long period of time. And it also gives you the modularity and loose coupling that enables you, according to Conway's law, to structure your development organization as a set of loosely coupled, autonomous, small teams. It's important to remember that the microservice architecture is not magic pixie dust. It's not a silver bullet. Sprinkling microservices on your organization when you have, for example, poor code quality, lack of automated testing, or a poor development process isn't going to address those issues. What's more, it might even make the problem worse. So, if you determine that you really do need to adopt the microservice architecture, how do you go about doing that? This leads to the third principle: migrate to microservices incrementally. The process of transforming a monolith to microservices is a form of application modernization. A key best practice of application modernization is to do it incrementally. You do not want to do a big bang rewrite. It's far too risky, it takes longer than planned, and it also means that you won't be able to deliver the features that the business needs today until far in the future. This approach is called the strangler application pattern. The key idea is that you incrementally migrate functionality out of the monolith into a new application, which is known as the strangler application, which in this situation would be made up of microservices. The name comes from strangler vines or strangler figs that grow in rainforests. This picture of me is taken in Singapore last year. I'm standing in front of a tree that has been enveloped with a strangler vine. The vine starts its life in the tree's canopy, grows down, establishes roots. Ultimately, it actually shades out the tree, which then causes the tree to die. So that's the general approach that you want to use when migrating to a microservice architecture. The evolution of your architecture looks like this. In the beginning, you just have the monolith, and then over time, more and more of your application's functionality has been migrated from the monolith into services. What's more, you could also implement the new features, especially those that the business needs today, directly as services. The monolith gradually shrinks and might ultimately disappear. At each step of the process, you identify a candidate module inside the monolith and then rewrite the code to convert that module into a service. It's important to remember, however, that you're not just transforming the code. You actually transform the database schema as well. In other words, you extract out the module's tables out of the monolith's database and move those into the service database as well. Quite often, untangling the data is actually the hardest part of the process. You also need to implement integration glue that enables the service to access functionality and data inside the monolith and vice versa. You can also implement new features as services. This is particularly useful because it enables you to quickly demonstrate the value of using the microservice architecture. And this is essential for maintaining the support of the business that's basically funding the transformation effort. It's important to begin the migration effort with a clear idea of where you want to end up. When using microservices, it's essential that you define the service boundaries correctly. This really is the most important decision that you must make, because if you don't, you can end up with what's known as a distributed monolith, which will actually slow down development rather than speed it up. This, by the way, also means that all of the technology-related discussions that we have around AWS versus Azure or Docker versus serverless, while at some level they are important, they pretty much pale into insignificance when it comes to defining your microservice architecture. So in other words, service boundaries are the key decision that you must make. You should begin the migration effort by defining your ideal target architecture. Now this is an architectural definition effort that should take a few weeks rather than a few months. You want to have a clear idea of where you want to end up, but you don't want to suffer from analysis paralysis. You really just want to get going. You should also treat this architectural definition effort, or the output of it rather, as a work in progress and be prepared to revise it along the way. Now, since a microservice architecture mirrors the structure of your business, it's really important to have a good understanding of your business domain. And for that reason, I strongly encourage the use of techniques from domain-driven design in particular event storming, because that can help you achieve a good understanding of the structure and nature of your business. It's important to not take the term microservice too literally and define an excessively fine-grained architecture. That simply adds complexity without giving you much benefit. And instead, you should strive to have a coarse-grained architecture where each team has one service. And a team should only define additional services if it solves a tangible problem, such as speed up development or solve some other non-functional requirement. A defining characteristic of the microservice architecture is that the services are loosely coupled. There's two types of coupling: runtime coupling and design time coupling. Runtime coupling occurs when one service cannot respond to a request until some other service responds to it. So in this example, the order service handles a post request to create an order by making a put request to the customer service to reserve credit. Now, this seems super simple. The problem is that the create order operation cannot succeed unless both the order service and the customer service are up and running. So availability is reduced. Also, it increases latency as well. I've done architectural reviews where, the client discovers that key REST endpoints actually are implemented by calling 10 or more services synchronously, which means that the business is at risk of not meeting critical third-party SLAs. To avoid runtime coupling, you should strive to make services, particularly when they handle update requests or commands, you should strive to make them self-contained. A self-contained service is a service that can respond to a request without waiting for some other service to respond to it. And there's a couple of different ways that you can achieve this. One option is for the service to maintain a replica of the data that it needs in order to validate a request, which means it doesn't have to actually go out and fetch that data synchronously. Another option is for a request to initiate what's known as a saga. A saga is a sequence of transactions in multiple services that are coordinated by the services exchanging asynchronous messages. The second type of coupling is design time coupling. This occurs when a change to one service, such as an API change, causes other services to change in lockstep. The problem with design time coupling is that it requires coordination between the teams, which reduces productivity and so runs counter to the goals of the microservice architecture. A good way to avoid design time coupling is to design services that look like icebergs. In other words, they have a small, stable API which encapsulates a large, complex implementation. And this enables the implementation to change without causing breaking changes to the API. Now, you could think of some popular web services like Twilio or Stripe that at some level have conceptually quite simple APIs that hide a massive amount of complexity, such as global payments or global messaging. Services should also avoid using shared libraries that contain business logic that can change. That's because when that business logic changes, all of the services that use that library need to be updated in lockstep, which once again requires coordination between teams. Also, a service database should be private to that service. That enables the schema to change without coordinating the work with other teams. If you have shared schemas, it becomes difficult or impossible to change those schemas. So far, I've described how you need to incrementally refactor your monolith towards your target architecture. But where do you start? The next principle I'm going to discuss answers this question. At each step of the migration process, you want to focus on extracting those modules that give you the greatest return on investment. Converting a module to a service has several benefits. Typically, it accelerates development. This is valuable if that module is implementing business logic that constantly changes. It can also improve testability, which will ultimately improve quality. It might also address other issues such as scalability and overall reliability. But at the same time, you have to consider the cost of conversion. It takes time and effort to convert a module into a service. In particular, you have to decouple that module from the rest of the monolith, and that can be extremely time-consuming. For example, extracting a module that has fewer inbound dependencies is usually easier than extracting a module that has lots of inbound dependencies. That's because you need to make fewer changes to the monolith. In this example, if you wanted to extract module C, you would have to change module A and module B to call the new service. Whereas if you wanted to just extract module A, that would typically be easier because it only handles requests from the outside. Consequently, you would probably just want to extract module A first. A good way to visualize priorities is to organize the application's modules on a cost-benefit matrix. You'd want to focus on those modules that are in the top right quadrant. The last principle I want to discuss describes how to measure the success of your effort to migrate to a microservice architecture. Success is not measured by counting the number of microservices. There's no inherent value in having services. What matters are the benefits that you get. There are two types of metrics that measure success. The first are improvements to the DevOps metrics. Most notably, you want to see significantly reduced lead time. That's the time from a developer committing a change to that change going into production. You also want to see the deployment frequency increase significantly. Yet at the same time, you want to see the reliability of deployments increase as well. The second type of metrics that you want to see improve are those concerning certain software quality attributes or ilities, such as availability, scalability, reliability, and so on and so forth. So that's my talk. In summary, here are the 6 principles. I hope that you found my talk useful. Thank you for listening.